What have been some of your favorite research projects that the center has done?
The center, again, we have a 30-year history. And one of the reasons why when I agreed to take this position is because of the long track record of delivering valuable information, valuable science for years. So I can give you a long list of accomplishments of our center. But before my time, I want to recognize the fact that the center has been around. It was around 24 years, almost before I arrived. So some of the projects that were very instrumental in making our center what it is today is because earlier researchers such as Mike Doyle and Dr. Larry Bouchard, who's been one of the most they both have been some of the most accomplished some of the most accomplished food microbiologists of our generation. They worked in multiple projects that at a time they were really pressing and it was critical to address, and they definitely delivered some valuable information. So, for example, some of the projects that they work on is they work very early on E. coli 0157H7, which is a major foodborne pathogen that companies are very concerned about, and unfortunately they continue to cause problems. So they develop a number of strategies to solve those organisms. For example, Dr. Dell developed a competitive exclusion set of cultures to reduce their presence in poultry and E. coli 157 in cattle. Then they first were one of the pioneers developing some of the early assays to detect Listeria monocytogenes, Campylobacter jejuni, that were also pathogens of very much importance. Another faculty that retired from here, Dr. Marlene Erickson, she worked very actively in elucidating some of the mechanisms, how pathogens were able to internalize inside of leafy greens, or whether assessing the risk of internalization. In general, a number of faculty work to address the understanding of E. coli 157 ecology in animals and in the crop fields. And there has been a number of researchers, including myself, working on developing thermal inactivation models in dry foods of salmonella and other foodborne pathogens, because we've had cases of outbreaks caused by a number of different dry foods like nuts, seeds, flour. In my laboratory, after I arrived, we developed a number of models to work on wheat flour and determine survival of enterohemorrhagic E. coli and salmonella on wheat flour. So the list is endless. More recently, too, some other faculty that are currently working in our groups. I've looked into some other projects that involve, for example, creating bioinformatics tools that may be useful to track and characterize pathogens. Dr. Shangyu Deng is known to have developed one of the first tools that serotype salmonella using a whole genome sequencing. And that tool is available for thousands of people online, and they can just access this tool. He developed that. And currently, for example, Dr. Matt Kazim has found some interesting trends in finding antimicrobial resistant genes of much of a concern in some potential not pathogens, but potential organisms that could transmit the genes to other pathogenic organisms. So the list is endless. In some ways, I can go on, but I think the message that I would like to convey in this chat is basically that our center has a long track record of contributing to address the most pressing issues that we face in food safety.
That's amazing. What are some other current projects that are going on?
One of those is, for example, Dr. Chan Yudeng again. He is looking into the interaction of E. coli 157 with leafy greens leaves. As you probably heard, is romaine lettuce has been one of the concerns for the several outbreaks that we have had in the last 5 years. So he recently got a grant from USDA to study how the organism interacts with those leaves. In the case of Dr. Malaki Zaili, who is one of our biologists here, she has been actively looking into and survival of the virus, the coronavirus, the pandemic virus, the survival of SARS-CoV-2 on different surfaces, because they've been concerned whether the virus could survive on let's say, food packaging surfaces. And she has recently published work along those lines. She also has looked at ways that we can sanitize surfaces to kill this virus. Dr. Inés Ortega, for example, she's one of the internationally known experts in parasites, food parasites. And right now, the most concerning parasite is Cyclospora. Cyclospora has been very much in the news, and currently this year is not different from the last 3 or 4 years, is that we had a number of people getting sick from this parasite. And the typical vehicle for this organism are leafy greens or herbs like cilantro, parsley, basil. So that's been causing a lot of problems. And she is looking into issues. She's been looking into ways to reduce the incidence of this organism in those commodities. In my case, a couple of years ago, we were fortunate that we got a grant from the USDA again to work on blue light as a novel intervention method to treat surfaces and kill pathogens. We've had initially first funding from the Center for Produce Safety, and more recently the USDA. So we have a number of researchers looking into the effect of this technology to try to kill not only bacteria but also viruses on surfaces that could be in contact with foods. So that's in a nutshell some of the highlights of the current projects happening here at the CFS.